Just to introduce myself, my name is Mason Kresge. I am a business development manager here at Oxipital AI. Today I'm going to walk you through how V-CORTX is an innovative produce inspection tool that requires no code, no labeling, and just results. If you haven't seen Oxipital AI before, we do things a bit differently. I really like to highlight, rather than conventional tools where you have to do 2D labeling, think of those annoying CAPTCHAs that you see on a website where it says, prove you're a human, click all the bicycles, right? We don't do any of that. Instead, we start with a 3D scan, and typically, from the customer's point of view, you start with a pre-trained model that has the capabilities to see the various components of an object, whether it is the object itself, rot, damage, or whatever characteristics you're looking for if we build a custom model. So let's just dive right into this. V-CORTX optionally runs on the cloud, but I'm going to be showing a bit of the cloud today, as well as on the edge device, which requires no internet. So I'm going to start with the model manager. I'm going to treat this as if I am a new customer. I just installed a vision solution and I just need to get up and running. I want to make sure that inspection works the way I need to. So I will assume that I am a produce manufacturer. I might have multiple products running through my facility and I need to swap between broccoli and corn and peppers. We have all different models trained up, and if you need to see something new, feel free to recommend new objects. We're always trying to add in new models every day. We have a target of training a lot by the end of the year, so I'm excited to at least show some of them. For today, I'm going to focus on corn. We can purchase this if you want to run corn. I have this already purchased and installed onto the system, but just to show some capabilities, if you want, you can pick and choose if you want it to be just identifying husk, or if you need it to also identify tip fill or rot, right? We have all different parts, so stock as an example. In this case, I'm going to be focusing on good corn and too much husk. I have those selected, as well as tip fill, and those are deployed to the cell. If you needed to see something new, maybe aborted kernels or kernel damage is something your team needs to see, just contact sales. Otherwise, we'll give you general stats, the processing speed, and the classes and components we can identify. Now, if you've never seen how we have done training, I recommend checking out Anthony Romeo's previous webinar. It'll go through kind of how we train it and how we get to a working state. But just to highlight some things, we can look at some 3D models. Now, we do start all of our models with 3D scans, which can sound a bit scary. A lot of people will look at this and say, how do you even make that, right? There is no CAD model for corn, especially my corn. So we have a 3D scan in-house, like a scanner, proper if you need sub-millimeter precision. It's something that's capable of. Otherwise, for a lot of produce, I recommend my customers to use an app. Your cell phone can create an object model that looks just like this within the actual active time is probably about 1 minute. But if there's ever scans we need, I can always train anyone how to do this. So this is the foundation of our ML models. If we look at another one, let's take a look at this guy. Once it loads in, this one has a lot going on to it, but this is where we start. So we would work with quality teams to identify what is important for the model. In this case, we have quite a bit of silk, as well as husk, and a stalk. What's really nice about how our models are trained is we can augment these. They go into a physics engine, and you can imagine we can stretch them, warp them, twist them. For deformable objects, we can make it so that they deform into each other. You can think of how tomatoes can nest together as they roll around. Some may be shiny, some may not be. We can simulate all of that. And it builds out a really strong foundation for a model. Now, we typically only start with, let's just say, 5 scans of good, 5 scans of class A, class B, from there. And what we'll do is, like in this case, we'll identify damage, and we can put that damage on any of the objects we have. Same thing with the husk, the stalk. And by having these roll around in different backgrounds, different lighting scenarios, they organically create different scenes. And rather than having you go there and draw around this corn and say, this is the good, this is damage, it'll automatically be annotated. But from your perspective, the customer will typically have that model, and they will need to configure it to their needs. So we'll start with the object itself. So what is this? This is corn. You can name this whatever. It just changes what this is over here. Model. We already have the model selected, but you can, this is where you would choose which parts matter. Maybe you're not doing inspection for rot, but if it's built into the model, I always recommend building it in. And you can give descriptions. That way if someone else is working on this and maybe you have some proprietary terms or something that isn't just standard like language talk, you can name it what you want. So maybe black rot versus brown rot. This is where it gets kind of interesting. So we can dive into the defects. It's a bit unintuitive at first, but I tell people we do not tell your system whether or not an object is good or if it is bad. We give it the ability to see things, which was all of these parts, right? So it could be aborted kernels, it could be damaged kernels, it could be the stock husk, right? What is good and what is bad really is dependent on the customer. It could be either for your own internal reviews, or it could be someone like your Walmart, your Sam's Club, right? They have specific specifications that they need their products to hit to be able to be put onto shelves. So how do you define that? It's actually really simple. You can add a defect, but I'm just going to edit excessive husk. What you can do is you can add that and you give it a name, whatever you want. It doesn't really matter. Same thing for the description. It just kind of changes what you see on the side, and it makes it easier for other people to pick up the work. From there, we can say what part is this related to. In this case, I am saying it is related to the husk, but if it's related to corn, it's as simple as just adding that. What you'll see here is this display color. It's just so when we do the highlights, it's a nice clean color. As an example, you don't want to use a yellow outline for your corn. It would blend in, make it hard to see. And then you can add scenarios. It's English programming, so you can think of it as a bunch of and or gates. So this product is defective when all of the following are true. For something like husk, it's pretty simple. I would make a rule that says something like the corn husk area is, if it's greater than some percentage, then it is deemed excessive husk. There's a lot of things you can do with this tool, right? Let's say it's not an area and you're just like, okay, if the husk length is greater than some value, you can just put that value in. But I'm going to stick with the husk area. I've seen that work really well multiple times. So the husk area is greater than something. You could also do percents if that's something that works better for you. So as an example, yeah, let's do husk area percentage. Husk percent. Part area percent is greater than. You can put in some value. Let's say we put in 35. This is just a gut, honestly, me kind of guessing what is an excessive area, but we can tweak this. So what I'm going to do is I have this bullseye clicked right now. It's highlighted as a parameter. I like to do that for anything that is not locked in, so it's not treated as gospel. Think of the USDA may claim that your corn needs to be greater than some minimum, right? Or your tomatoes need to have some length or diameter minimums. This is where this is exposing it so that you can edit those per customer. So I'm going to confirm this and go into profiles. This is where you can build out your Walmart, your Sam's Club, your Whole Foods, you know, whoever your end customer is. You can edit these, name them, and they give you different drop downs, so you can track each one individually if you would like. And for anything that has a configurable parameter, which is that bullseye, you can tweak it here. So it makes it really easy to edit 6 to 10 recipes if you have a bunch of different customers. Same thing for dry tip, which is also revealed. Okay, and from there we would apply changes, and we would get a deployment package. I'm not going to generate this, it takes a little bit of time, and I already have a base recipe on the cell that we'll edit. So now that we have the cloud configured, what we're going to do is we are going to go onto the cell itself. I already signed in, I've got a few recipes in here, but today I'm going to focus on just corn inspection. We're also able to go into pick view, and then you can do test. I have 2 windows because I like to split the cell for when I am doing edits. So what you can see here is I now have a side for my recipe editing, as well as what the actual camera sees. This becomes a bit of an iterative process, but it's really simple. So you can just go down and let's take a look here. We can test the scene, see that this is deemed too much husk, but this one isn't, right? For each customer, it may be a bit different, but let's say we need to see what is going on here. We can go in and see that there is not too much husk. I'm going to actually blow this into the full screen so that it's easier to see what's going on. Okay, so we can go in, see this object. The object itself has an area of about 20,000, and the husk itself has, let's just call it about 5,000. So I just need to tune this down just a little bit. Going to the other window, I can go into my inspection rules. The maximum husk area is 35. Let's just make it 15. Right? I want to be much more aggressive to this, so I'm going to save and exit and reload this. Just takes a second to come up. Just needs to do a bit of thinking. But once that's ready, I'm going to test once. You can see we've identified it as too much husk. Conversely, if we want to say we need to allow windowed corn, which for those of you who are not in corn, it allows you to see if basically you would husk a portion of this. It's almost like this one, just cleaner, where a certain number of rows of kernels are revealed. You can do that pretty simply. So we can edit this, and let's go into the inspection rules, and let's call too much husk if it's, let's just say 40%. Save and exit, and reload. Same thing, just takes a second. And now you can see we are only identifying this one as too much husk because we have deemed by our quality team that these are acceptable levels of husk. I would do this with multiple pieces of corn, roll them around, rotate them, and then just make sure the rules still make sense to what you believe, right? I've seen it time and time again. A lot of produce producers go, it's about this big, and everyone's thumb's a bit different. So treat this as your qualities team's Bible, if you will, right? This is exactly what you want it to be. All right, now that we have it working on the cell, what we can do is we can go onto the cloud by enabling inspection. This allows it so that the data that you see running in your production facility gets pumped up to the cloud, and you can keep track of trends. I'll open this up, and I will go into overall summary. Just load in a bit of data. You can do this live if you want to see it constantly update. You can also choose different time frames. I'm going to stick with today, that's fine. We'll load that in, and you can see from 5 a.m. to about 10, we've inspected almost about 7,000 units. We can increase this window, zoom into specific times. Let's say we see a drop in production, or in this case, we are tracking yield. We're doing pretty well on yield, but around 8 a.m. there's a huge drop. We can zoom in and see what exactly happened at this time. You can see we have this big dip around here. This is important because you can track anything from your equipment to personnel, see how efficient they're working and if they're doing things well. But I'm going to increase this back to today, just to have more data. And then from each time frame, we're able to see the defects, so the quantity of those defects, as well as the specific number of what type of defect. This is where things get pretty powerful. So I've seen this data get used in multiple ways. One is the most simple. Okay, we see a bunch of excessive husk, give operators an alert to say, remove extra husk. I've seen this get correlated all the way to grow conditions. We see we have a huge amount of dry tips from the shipment from Farmer John's. So let's see what his grow conditions are. Maybe we need to increase watering for the next year. All the way to just, keeping track. Maybe there's something you can do upstream or downstream even. Excessive husk. Maybe you have a husker, and this is giving you the warning signs that you can clean it up a bit, and that will increase the efficiency. What's really cool is we save the data typically for about 30 days. This is all configurable depending on your needs, but it's all the images that get wiped after that time period. But for this last 30 days, we can go in and see all examples of excessive husk. Once again, it gives you the overall trend, as well as if you go in, you can go into specific products. In this case, I've identified that it has excessive husk. It has some tip issues, not enough to be called a defect. Once again, that's the configurable part of it. We can see how the corn itself is getting identified, as well as the portion of the husk that's identifying. Gives you the overall stats of your objects. Once again, you can correlate that to the grow conditions or just back to your recipes, right? You need to make sure that your products have some size. Okay. And same thing if we go back to overall summary. You're able to do that for all of the good products, the dry tips. Gives you the overall trends. And we can take a look just to see, okay, this one's interesting because we have the overall piece of corn being identified. We have some amount of husk, as well as some portion of tip fill issues. All can be identified, and you can see all the defects broken into their individual components. All right. So, just want to end with a bit of Q&A. I've pre-canned some of these just so that they're kind of the things that I hear frequently. So, what level of control do I have over the application? So, you can actually drive the model development. We are working on tools to allow customers to get their hands on and start creating their own models. But for now, you would give us guidance, and we would be able to create the model to allow it to see the various objects. From there, you can edit those rules, like I saw, to determine what the defects are. And if we give you the ability to identify things like damage, there might be different types of damage that the rules are able to segregate. So you could think of very long amounts of damage could be bird damage. Very stout damage could be mechanical damage, and you can break those up into the individual rules. What kinds of problems can V-CORTX solve? It's a very powerful tool. There's a lot of things you could solve. You could do anything from giving quality inspection in a grow facility all the way to doing robot picking and guidance with inspection rules. So thinking of, I only want to pick up good products and place those into tray line 1, or I put my grade B products in tray line 2. Other ways you can use this, I've seen it get used to correlate grow conditions. It's great for greenhouses or just correlating your yield for the fields, all the way to incentivizing workers based on their performance. You can track the throughput and the yield and go from there. Do I need AI or coding expertise to use V-CORTX? No, not at all. I don't have a coding background. I have very minimal experience creating ML models from scratch. But you can see from today, you're able to just use plain English to tell the system what you're looking for. It's versatile, so you can just, if you run into something, you can give it a try. If there's a rule that you need, give us a contact and we can always see if we can build it in. Simple rules like this are pretty easy to add in once the model's made. Alright, thank you for joining in today. If you got any questions, my email and my cell phone are on the screen. Catch you later. See ya.